what is there in Dept Ece series and what we have done, that will be the discussion of today. And I'll also probably announce that some of your seniors were a part of our team. They worked in our team in the development of this Dept Ece series satellites, transponders, TTNC transponders, as well as one more thing which is not mentioned here, RISAT. That was the recent one what we have delivered to ISRO. And so far we have developed this C-band some 15 satellites, some 15 transponders, and here we have developed delivered some 8 transponders. Okay, when we say transponder, what are the constituents or the components of the transponders? A transponder is a device. Any of you know what is transponder? Yeah. See, the purpose of a transponder is it will be positioned in it's a part of satellite. So we will be sending some information, and it will be received by an object. It will be retransmitted to the Earth station. So if I have to see means I have a vision limitation, so I can see up to that. So I cannot communicate to a person who is outside the room. So line of sight, there is a problem. So what we do is we send the signal what we want to send to the other part of the Earth. So that we send to satellite. Satellite will retransmit to the other portion of the Earth. So for that purpose only we use satellites. And transponder is a device which receives the signal. The signal strength will be very low. So we have to have an amplifier for it. Then retransmit to the Earth station. So transponder is nothing but a receiver, an amplifier, and retransmission. So this is the transponder. And we have, as I said, 2 set of transponders. For depending upon the application, we choose the frequency band. So here we are going to talk about only S band. Again, there are 2 different modes of operation, coherent and non-coherent mode. Means Earth station, let us say it may be in Hyderabad or in a tracking center in Austin, Bangalore. So this will have again Earth station transponder. It will be a transmitter and receiver. So this transmitter will be sending from the Earth station, will be sending a signal. It goes to the satellite, and the satellite, this onboard transponder receives the information, retransmit to Earth. So in Earth station, we have a crystal oscillator, which will be operating oscillator. So both has to work in the same frequency and phase. So any signal will have 3 components: amplitude, frequency, phase. So in a satellite which has got this coherent mode, so the phase information is retained. Means Earth station transponder and onboard transponder will be operating at the same phase. That is taken care in this coherent mode. And for higher resolution, we use only coherent mode for these TTNC transponders. And see that so this 3 boxes are there, which we can discuss it. Okay, so that's about transponders. And what is TTNC? It's the purpose of that transponders. As I said, in a satellite, several components will be there, like a battery, solar panel, and mainly these transponders for communication purpose, sending and receiving information. So the purpose of this particular transponder is TTNC. The application of this transponder is TTNC. Tracking, telemetry, telecommand. Okay, means you can track the whereabouts of a satellite. That's the first activity what we have to do. So we should know where exactly the satellite is standing, and we have to send some command to position exactly at a particular orbit or an angle or inclination, all those things. So that can be done by telecommand or command, simply we can say. And telemetry is the health of the satellite. Normally we say it's a health of the satellite. Like several components will be there, like battery and all, whether the battery is functional or some portion of damage, all those information. So there will be a provision for sensing those things. And the sensed information will be digitally modulated. Then again it will be analog modulation at higher frequency, which will be transmitted to the Earth station. for corrective and preventive action, and depending upon that we will be sending telecommand signals to change the course of satellite policy. So that is the purpose of the TT and C transponders. So these are the things. So and telemetry, what we do is sometimes we capture some signals that we have to send back to the next session. So this satellite will be continuously rotating. IRS satellites, it makes a rotation probably 90 minutes or so, 1.5 hours. It will make one complete rotation about the Earth. So it will be visible to a particular Earth station for a few minutes only. So remaining part of the non-visible region, the information will be stored in a onboard computer. So that has to be transmitted quickly to the Earth station. So that is called the playback signals. So these playback signals will be sent back to the Earth station during this telemetry operation. So this is the main transponder, without which you cannot have a communication with the any satellite. So if you take any satellite, one TT&C transponder has to be there. Other transponders which may be there, may not be there, it may work, may not work. So it's like a heart of the satellites. If you are able to communicate with the TT&C transponders, yes, we can track the satellites, we can do something with the satellite. If we could not, and we can pulse the brain of the satellite. Okay, so as we said, the transponders has three different, coherent transponder has three different sections: receiver, local oscillator, and transmitter. And these are the we call the package. One transponder is an unit, how we refer in our project. And a unit will have three boxes: receiver box, local oscillator box, and a transmitter box. And these are the flight packages, what we say. Means it will be in orbit. We develop a different level of package, experimental packages, flight packages, laboratory levels, so different levels of that. So we refer it as a flight package. This is actual flight package what we have developed, and we have sent to ISRO, and it is now working in the orbit. And this will be a part of the satellite. These are solar panels, what you can see. And this is the satellite, and that will sit in the nose of this rocket. And this rocket may be a PSLV rocket or a GSLV rocket, depending upon the application of the applications. Okay, so since it is very important, we cannot use this TT&C transponders. We normally have a similar package. So two packages will be developing. The one is called the main unit, the other one is returner. Both will be on all the time. If one fails, we have to go to the next one. Automatically it will switch to the second one. So simultaneously we develop two units, means 6 packages: 2 transmitter, 2 receiver, 2 transmitters. So these are the things. So similar packages, similar frequency, similar power level, all these things we will be maintaining. And this is the circuitry or block diagram of a thing. So we have a antenna, and it goes to the duplexer, and there will be a filter also. The power divider will fit main unit as well as the returner units. So you have 2 receivers, 2 local oscillators, and 2 transmitters, and there will be a signals. So this is the setup. So main and returner. Okay, if you see the block diagram of signal flow of a transponder. So this is the S-band signal what we are receiving. It's a modulated information. So as I said, there will be 3 different kind of information. One is tracking signal. These things will be in kilohertz only. So tracking, telemetry, telecommand. So this initially what we will be doing is we want to assure the position of the satellite. So ranging is the signal which we will be sending. So that so this signal will be coming to the receiver. It will be getting demodulated. It goes to the transmitter, and transmitter retransmit to the earth. So delay in receiving the signal. From that they derive the time taken to and they identify the distance. That is how they find out the position of the satellites. Second is the telecommand signal that will go to the different parts of the satellites, and again telemetry information which is taken from the satellite will comes to the transmitter and goes to the that session. Okay, this we will talk later. This is a transmitter. So if you see the block diagram of a transponder, so this is the RF signal which goes to the low noise amplifier, which amplifies the signal. The signal will be very, very low, maybe in the order of minus 50 dBm. We use dBm, decibels, as the unit for our discussion. So it ranges from minus 50 dBm to minus 120 dBm, depending upon whether it is in apogee or perigee. So this goes to the LNA, and it is first down converted. It goes to something around 200 megahertz, and again it is down converted to 10.7. So this signal, modulated signal, will be in this 10.7. That is, from this power divider it goes to the demodulation unit. So here we expect two signals. One is ranging signal, the other one is a telecommand signal. So this is this demodulation unit. And this portion is the local oscillator. So this signal is down converted, and here we have a very narrow filter which filter out only the carrier. So this carrier signal will be fed to this VCO. Here one local crystal will be there, both will be big. So this is also at the same frequency, this is also at the same frequency. The error in the signal or the phase difference will be compared, and it will be fed to this both the units. So the error will be corrected here. That's how they get the phase synchronizations. Whatever error between this frequency error and phase error in this crystal, local crystal, is getting corrected with the incoming signal. So this is done in the local oscillator. This is the transmitter which we will discuss in our. So transmitter, if you see the same signal, they derive 377 megahertz. That's the carrier which gets amplified. In between we get the modulating signal. So this is a 377 megahertz signal coming from the receiver. So once it is coming, we call it is working in the coherent mode. So this coherent signal will be coming from this receiver, and will go to the phase modulator. Phase modulator, it modulates it, and it is getting frequency up converted to S band, and is getting transmitted. When this signal is not available, we can locally generate the same 377 megahertz and operate. So this is about the total size and weight of the satellites. You see both the main and return put together maybe of 10 kilogram, and the satellites weight maybe some 3000 kg or so. That's about the transponder. I'm going to deviate from the topic. We talk about something electromagnetic interference, and we'll come back to this. How many of you have experienced this scenario? Hold it, please. If you go close to some device, your hand just you are done. And these things, when you hold the hair, some piece of this is a regular thing what you are doing. So what is it called? Fine. So how it is happening? That's what we will discuss. See, this kind of spark it goes to the device. What will happen? Okay, there are three ways through which this process can happen. So when you walk on carpet, what you do is this. The charges, a neutral atom will give up some electrons, or it may appear some electrons, it will become positive or negative. So this static charge, in this body, once you get separated, this will be staying in this shoe or this floor. So it becomes negatively charged, this becomes a positively charged object. So this charge stays in the object. So that is why it's called a static charge. So this electrical charges stays here, maybe in the order of 1500, depending upon the humidity. If the humidity is very high, accumulation of charges will be less. If there is no humidity, it can go up to the level of 30 kilovolt. From this kind of volts you can see in Gulf region, wherein the humidity is very, very less. So when they touch this knob of door, they will get heavy shock. So normally all those high laboratories, they maintain humidity around 45 to 60 degrees. So these are the things. So there are three ways, friction, separation, induction methods. If you go close to a device which is already charged, if this device is positively charged, if I go near, the neutral atom in my hand, what will have to give up some electrons to the surface of this thing. So this portion will be a negative, whereas this will be positive. So my charge becomes a negatively charged thing, and most of the things will be at the tip. So this is a series, what they say. Normally these materials which are listed at the top will try to give up electrons and becomes positively charged electrons. Whereas this one acquires electrons and becomes negative. If these two particles, this glass and Teflon, come in contact, it becomes electrostatically charged device or material. Okay, this material, if it comes in contact with the opposite charged thing, or if it is getting grounded, what happens? A rapid, quick reunion will happen. So what happens in effect? Heat and melting effect. So this can damage the components. Why we have to? So there are three ways of such things: human body interaction with the device, or in a conveyor belt, and when the belt is rotating or transporting some items. This belt is a plastic material. It will acquire some charge. When it is getting in touch with some electronics, this charge will get transferred to that quickly and will damage the electrons. So this is one model. And whatever we use this materials, we take the electronic components in an enclosure or in a hand. So this materials what is maybe a plastic enclosure or this, that also can have some charges. So there are three ways of discharging high voltage, electrostatic voltage to this device. So they have developed the three different models, and these are some of the damages what it has caused. This accumulation of charge will be in the order of kilovolts. This will be in the order of some few hundred volts. So any component can get damaged even for a 30 volts electrostatic charge. We can tolerate up to 2000 volts ESD signals, but the devices cannot handle even 30 volts of things. So these are the sensitive devices. Anything which you don't know, assume that it's a ESD sensitive device. That's how we go about it. This is how they classify it. So there are internationally it is classified like this. So device to device, these are the levels. Even 120 volts also can damage the device. So what are the type of devices? Damages, failures, catastrophic and latent. This normally happens during the fabrication time, and this may be during handling the package for testing time or this thing. So here what happens is the device permanently get damaged immediately after the electrostatic event, discharge event. So it has occurred a discharge, then it will not operate. So we can easily identify the failure. Whereas here is the biggest nuisance. It would have occurred, it would have, some event would have happened, which may not be knowing. But when we test, it will give the result. But over the period of time, it will fail. That's the biggest problem what we face in the satellite development activities. So this is a more dangerous scenario than the other one. Okay, this is about the ESD. Any doubt on that? Okay, so we'll go to the next section. So if you see the type of failures, they have done a lot of studies, and then most of the failures, ESD and electrically over voltage failures and fabrication, and these three things put together comes around 78%. So if you see, if you control the ESD activities and proper fabrication and assembly, you can minimize the most of the failures, and you can achieve 0% defective system. And why it is required? A satellite development, a satellite may cost around 150 crore rupees, and the rocket may cost 200 to 400 crore rupees per time. And it takes 2 to 3 years to develop one single set of satellite or transponder for us to complete the entire sequence. Right from we are not doing the design and the procurement, leaving out those two operations. Right from once the components are available with us, now I have to deliver a transponder. It takes 2 years for us to do it. So that highly skilled manpower And these are the things will go waste in no time. And the funny thing is we cannot go and repair in space. So we cannot afford to lose anything of that sort. Certain things, I cannot name the satellite in which we are. See, there was one failure. Okay, there was one failure. I should not name the country. What happened? Onboard satellite was working fine. TT&C transponder, the power supply comes from the battery pack to the transponder. One mechanical washer of 2 mm thickness sat in between, fallen and sat in between positive supply and negative supply. We could not get the signals. The entire satellite has gone waste. 3000 kg satellite we could not get because 2 gram or less than 2 milligram of material gone between supply and demand. And there are methods to identify the failures. So this was the thing. So such several failures are there. So that is why we are very much concentrating on this zero defect system. Okay, how to achieve this? So we have to incorporate this safety precautions and certain aspects like cleanliness in the fabrication process and assembly process, and even during the transporting the satellites to the launch pad. So this process involves, okay, these two things we will not discuss, fabrication and it goes to the assembly, and we do testing on this performance, functional verifications and environmental qualifications and all we will be doing, and finally it goes to the launch pad. From ISRO Bangalore, it goes to Sriharikota, 10 kilometers per hour they travel, so it takes 2 days or something like that to reach this place. So all through this thing, they maintain this. And apart from that, they will have an online QC for each and every activity. They will certify, test, reject, or approve the process. So, and if some problem is there, we have some preventive action schedule also. So this is how we go about it. Okay. So means what is clean room then? So clean room, these are the parameters we normally consider. We will stick to clean air and ESD, which we already spoke about. And unidirectional, these are the important things what we have to know about clean room. Okay, what is cleanliness? Human hair thickness is 100 micrometer, and we can see the size of 50 nanometer. And normally we are the more, people are the generator of this source of dust particle. And dust particles, if you see, it is 1 micrometer onwards. So this is the size of the dust particles what we are concerned about. Inside the clean room, if the fellow is fully grown, and if he is sitting in a chair, he can generate this much of particles, and it will be 10 times of that if he is walking around the clean room. And if you see 1 micron thickness particle, it will take nearly 1.5 hours, 48 minutes to fall from 1 meter distance or to settle to the ground. So it will be always on the air. And this, why we have to talk about this 1 micron thickness particles? These are the carriers. If you see this size of this dust, virus and bacteria, and that it can accumulate charge. It can take charge from one device to the other. If this is a positive charge, and this is also positive charge, it will be traveling from one region to other region. So it will accrue the charge, and it is a transporter of this electric charge. So what happens if I have the charge, and it will take the charge from me, and it will transport to a device. So even if you are keeping idle, that device can go back. So it is our duty to reduce the number of particles inside a clean room. So we can say why we have to invest such a amount. It may be some 2-3 crores we have to invest for achieving a clean room and maintenance of a clean room. See what is that? So people have classified, there are some standards for international standards for categorizing the clean room. So class 1, 10,000, 1 lakh. Class 1 lakh means in a cubic 1 foot by 1 foot, 1 foot volume, how many particles are there of size 0.5 micron? So that is how they classify. For space applications, we normally prefer 1 lakh. Class 1 lakh is the necessary thing for to fabricate any electronics inside the room. And there are different standards which we will not be out of topic. Okay, in summary we have class 10,000 and class 1000, which there are two different areas. This we are using for polymer activity, we say. Basically all chemicals and all will be kept in that room, and that's where we do that thing. And there is some type of filter, air conditioner. So this is called a HEPA filter. So what it does is the signal, this airflow will be maintained from the top. So it is a uniform unidirectional airflow, and the dust will be forced to settle down in the floor, and it will be returned through this circle. This is how we operate. And this HEPA filter is such a device that it can filter out even 0.3 micron thickness filters. And there are another kind of filter, ULOG, that can go up to the level of 99.9997 size level of filtration it can do. Okay, this is our clean room, so we have to leave our chappals here. And this is called a sticky mat. With barefoot, we have to walk and stand on this. We will remove the dust and the foot and all things. And you can see, these are the metal things, aluminum metals. So we have to stand for a few seconds before we, so that we get all the charges what we have occurred, will get discharged. And these things are called the ground conductors. So these are regularly, these are copper strips which will be connected to the air pit of 1 ohm or less than that. For every lab, we have to have a ground resistance of 2 ohms or less than that. So that is maintained here. And these are all electrostatically, anti-static floor mats. This is the air filter which air showers. And you see here, this is a handle. You see this handle also is grounded here. And once you enter, these are the things you have to wear, and these are no conductive anti-static metals. So whatever charges you accumulate, it will get discharged in a very slow fashion. And this particular thing is a particle counter. So we have to regularly measure the amount of particle in a cubic volume. So this is done with the help of this meter. We have several meters. We can measure the charge at any particular place. Those things we have to regularly monitor. There will be a person who will be checking day in and out. Means the moment is, this clean room will be operating 24/7. So every day he enters the lab. Before other people, working level people enters, the online QC will go and measure the particle count level, and if it is more, necessary action will be taken. There are some procedures. And then ESD level, there are some meters to measure the static charge at different locations, and it is specified in the standards, equations normally used to do. So there are some meters which will measure that, and there are alarms also. So if there is some ESD thing is happening, it will make some alarm. And this is how they classify this ESD materials. So if the material is of this surface resistivity of this level, it will not allow the charge to get accumulated. And next range is static charge, and these are conductors. So this type of materials only we will be using. This is an imported chair. Here the specialty is like that carbon is impregnated on this seat. So the moment a person sits on this chair, the charge will be discharged to this chair. This is grounded here. And this floor mat on anti-static floor mats. So the charge what he has accumulated will be immediately discharged to this specially made chairs, and will get grounded to the thing. So there will be a chain which will be touching the floor, and it will get to this ground. So these are the care he has to take before touching any electrical components. This is the mechanical. And here you can see a box which is called the desiccator. Herein we store all the electronic components what we use for the space applications. So several bags will be there. Means a device if it accumulates moisture content, so it will start oxidize and the corrosion will happen. So this water content level also inside a clean room has to be maintained. So what we do is we continuously pump nitrogen gas to this chamber so to absorb the moisture content. So in a day we may use some 2 cylinders. A cylinder may cost 1,500 rupees. So 365 days you can count how much money we spend for maintaining keeping the components inside this kind of chambers. And this is the laminar flow table what I told. Here only we maintain class 1000. So all chemicals what we use for IPA and all those things apply to the PCBs and what we do here. And this is a machine which generates ultrasonic waves. So we pour IPA and some waves will be generated. Before a PCB is taken out for fabrication or assembling the components, we put the PCBs in this machine and remove their particle size less than 0.1 micrometer thickness. So from that point onwards, we start taking care of the dust particle content. And the person, he is a fabricator, he is an online QC. See how this process is done. See, the moment he takes out the PCB and start counting with it, there are 2 types of temporary soldering and permanent soldering. So the moment he does this temporary soldering, it will be given to the online QC. He will check the position and the direction, all these things, and he will give back to this fellow. And he will make the permanent soldering of this particular joint. And that he has to do within a second or 2 or 3 seconds. He should do that particular point in a PCB, he cannot heat it for more than 3 seconds. That he will be inspecting. And the level of or the quantity of lead or the flux, how much he is applying there, he will be monitoring. Apart from that, he has to make an entry in the register called the history register. Register will contain every information of the entire activity, right from the PCB level and till we give to the latch pad. So all these things will each and every, this fellow will write whatever he has done, and online QC will be writing what he has done to find out where exactly the problem has happened, which point we have to attack to solve the problem. So everything is done at each and every stage, and you'll have a 3-dimensional 120x amplifier or magnifier. And he will be monitoring and will make proper records. And he is responsible for any failures, what is happening here. And you see all this materials, so these are all anti-static materials. So these papers also takes care of that, and he makes all the entry here. And when fabrication over, he gives to the testing fellow. Before a person takes for testing, he has to make entry that for this particular purpose, I have taken this particular card or PCB or whatever it is, and I am going to return it on such and such date on this time. And this is the exercise I have done. So all these things will be maintained. Even the cover what we use for each resistor capacitor, there will be a cover. 1 mm by 1 mm resistor will have this much of cover, anti-static cover. And those covers also will be keeping in the folders. We will pin this sapling and we'll keep it for future records. So that is how this clean room activity is done. Okay, that's about clean room. And let us talk about testing. So here in testing there are 2 aspects, qualifying the system for the practical functionality and environmental qualification, means space qualification. So what is the environmental condition in space? There are 2 things. One is temperature will be different. Second, it's a vacuum. So this electrical product what we are developing, the behavior of this particular electronics will be different in space. So what we do in lab is at 25 degrees centigrade, you make it all right, and that will be giving some output at 25 degrees. Even a resistor, if you see there is a thermal component in there, thermal coefficient in there. So if you vary the temperature, 1 kilo ohm resistor will not behave as a 1 kilo ohm resistor. If temperature varies, this 1 kilo ohm may be 100 ohms or maybe 1 micrometer. So the final result will not be of same what you got in the lab. So you have to take care of the temperature extreme, what it is going to face in the space. So when it is in orbit, it has to work in the specified range. So anyway, there are some tolerance. So this output what we are getting should have the same level of performance even in this space and that will back up. Okay, so two level of activities we have to take care. For receiver, local oscillator transfer into two, main unit and return unit. Okay, what are the process involved in this testing efforts? Once we come out of fabrication, we go to the testing. So once the fabricator fabricates the populate the entire card, this a control card, let us say it's one PCB. Card I mean to say is the PCB. So it's a populated PCB. So this comes to me as a test engineer. I will take the card and I will do it in ambient lab condition. Again in a clean room only. We will be doing the functionality test. And for which we have some thermal related test will be there. So we will be changing the temperature and see the performance. However, in 25 degrees, this is the output. And in cold, what is the output? When it goes to hot side, what is the output? Whether all the three are in the same level. So that is what I am making sure in this particular exercise. Okay, then sometimes we have to do some chain of PCBs to make sure that the particular chain is working fine. And then we go to the package level, transmitter package or receiver package. So independently we test the package. So these two things, no, we don't do the vibration test. And here only we do the vibration test as well as thermovac test. And once we done with this package level, then I call the other teams, transmitter team, LO team, receiver team, all put together, we do this test. Again, here also we do this same exercise. Finally, it will be given to the satellite. Okay, so I will just talk about the transmitter and how we go about it. So, as I said, there are two modes, coherent and non-coherent mode. If it is working in synchronization with the earth station, the signal will be received by the receiver and LO will be giving this coherent signal of 374.28 or 379 MHz. There are two frequencies which will be fed to this switch, RF switch. This is one mode. This is called coherent mode. And in non-coherent mode, there will be a T6O of 62.38 or 65 or 62.5, and it will multiply by 2. It gives, so you can switch between these two operations. It goes to the modulator. So modulating information will be there. This housekeeping signal, so playback signal, what is stored in the onboard computer, it's a ranging signal. So three different signals. So maybe some, this is of 100 kilohertz, 32 and 128. This goes to this. It's getting up converted, amplified and sent to the antenna. So these are the PCBs what we have, and the different stages. See, this is a coherent signal, this is a non-coherent signal. This is a different signal. So this is the performance of this RF switch. And this, I think it is not visible. So this is the performance of this hairpin filter what we use. And these two are the output of this amplifier. There are two stages. This is called driver amplifier. This one is the power amplifier. So the output of this will be right from now 100 megahertz. This would have been something around 6 megahertz, 6 gigahertz. So this is the signal, wanted signal. These are all the harmonics what you can see in a spectrum analyzer. And this is the modulating signal. If you amplify the signal, if you see, if you increase the resolution bandwidth, you can see what is there inside. This is nothing but a PM modulated signal. So if a signal is PM modulated, in a frequency spectrum, if you see, it will look like that. So this is about transmitter. Okay, this is how we name the card. ISO transmitter card, S-band transmitter card 012, this much. Okay, what you do in a card level. So once we testing and receive the card, he physically inspects it and see any physical damage. Then he checks whether everything is done as per the circuit what we have given. Then he does the functionality test. If there are some requirement, he will be tuning the card for best performance. Then once this is done, he will go to temperature, cold means minus 10 degree and maybe 15 degree depending upon the requirement, whether it's experimental satellite or for flight model. So this temperature will be given by the space agency. And again, maybe 50 degree or 55 degree. So first he will do with 25 degree, then 10 degree plus 50 degree, then he will come to 25 degree. So this exercise, each degree he will be doing for 2 hours, not 3 hours. Normally it is 1.5 hours to 2 hours. So once the temperature is settled, then you will make the measurements. So 25 degree, you tune the system, you put it in the chamber, go to minus 10 degree, measure the parameters. Assume that it is failing. You cannot open the chamber and tune any components or change the components. You have to come to for 25 degree ambient temperature, because if you open the chamber, there will be a condensation inside the chamber, it will spoil the tracks. So you cannot open the chamber at 20 degrees. So you are naturally going to wait for some time, maybe some 1 hour or so to bring to the 25 degree ambient temperature and leave it for some time. Then take out and give it to the clean room person. He will, you have to write the history. This for this particular purpose I am changing a particular component. That you have to tell and get a proper approval from the, for test also there will be on-time engineer who will be validating our suggestions or sanctioning our direction. So that we have to inform to the fellow. The funny thing is, any board, let us say one resistor, you cannot remove a resistor and resolder it more than 2 times. If there is a need to remove and put it again, 2 times only you can do. 3rd time you have to discard the entire PCB.